First thing we've got to do is divide this by x plus 2, and we're told that the remainder is minus 150. So that means that p of minus 2, because we're dividing by x plus 2, p of minus 2 equals minus 150. This is from the remainder theorem. If this is something you need to brush up on, there is a video that I've made on this as well. So from the remainder theorem, as I say, we know that if we substitute in minus 2 into this, we'll get minus 150. So we're going to end up with a equation. Let's do that. So minus 2 cubed, remember I'm putting my negative number in brackets, plus c times minus 2 squared, plus d times minus 2 minus 12 equals minus 150. Let's rearrange this equation here, and hopefully we should get this equation here. Minus 2 cubed is minus 8. Minus 2 squared is 4, positive 4, so this will be 4c. D times minus 2 is minus 2d. Minus 12 equals minus 150. Let's bring the minus 150 onto this side so that we have 0 on this side, and we get 4c minus 2d. Minus 8 minus 12 is minus 20. And if I bring this onto this side, I have a positive 150 equals 0. I then end up with 4c minus 2d minus 20 plus 150 equals plus 130, and that equals 0. If I divide this by 2, if you notice there's a factor of 2 that goes into all of these numbers, and I'm not going to lose a solution. Divide it by 2, I end up with 2c minus d plus 65 equals 0. And that is the same as that. So that's part A. Let's start with B then now. Okay, so given that x minus 3 is a factor of p of x, find another equation involving c and d. Okay, so if x minus 3 is a factor of p of x, that means if I substitute in a positive 3, I should get 0. This is from the factor theorem, and if you need a reminder of that, I've made another video on that you can find. Okay, let's substitute in 3. We've got 3 cubed plus c times 3 squared plus d times 3 minus 12 equals 0. So that implies that 27, so 3 times 3 is 9 times another 3 is 27, plus 9c plus 3d minus 12 equals 0. Let's just group these terms. We get 9c plus 3d. 27 minus 12 is 15 equals 0. Now notice 3 goes into all of these. So let's divide through by 3, and we get 3c plus d plus 5 equals 0. And that's for B. Now we've got two equations. We need to solve them simultaneously in order to find the value of c and d. So our equations are 2c minus d plus 65 equals 0. And we've got 3c plus d plus 5 equals 0. Now I can solve these by elimination. I'll label them 1 and 2. And if I add 1 and 2 together, I can see that minus d plus d here will equal 0. So I will eliminate the d term. So 1 plus 2 will be 2c plus 3c is 5c. Again, minus d plus d is 0. 65 plus 5 is 70. So plus 70 equals 0. So 5c equals minus 70. So c will equal minus 70 over 5, which is 14, minus 14. So if c is minus 14, then d, let's put it back into one of these equations here. Let's put it back into equation 2 first. 3 times minus 14 plus d plus 5 is 0. 3 times minus 14 minus 42 plus d plus 5 is 0. Group these together, we end up with d minus 37 equals 0. So d equals 37. And we can check by substituting into 1, substituting in both values into 1, and we will get, that would be 2 times minus 14 minus d, so minus 37 plus 65 should equal 0. Let's see if that's true. Minus 28 minus 37 plus 65, and that does indeed equal 0. So my answers are C equals 14 and D equals 37.